This is making graphs of a straight line that have an inequality symbol instead of an equals sign. Okay, so I've actually got a nice little comparison right here. There's the equation, and here's two very similar inequalities. So I want you to think just kind of numbers-wise, math-wise, what is the big difference between each of these three? Think about it, pause, and then come back. Okay, so for this one, all of these do have infinite answers, right? Okay, that's why we graph. We graph to make a visual representation of all the different answer possibilities. However, for this one, for A, our answer is really just a distinct line. That's really all it is, okay? All of our answers will fall specifically on that line. Now, I haven't graphed that line on a piece of graph paper. I would need to do that. But all of our answers fall on a line. For these two, things are a little bit different. Here, our answers will fall on that line, but there will also be one entire side of the graph that also contains a good range of possibilities. It might be this side, it might be this side. It won't be both, though. And it'll have to be one side or the other, right? So like one side of that line will contain all the values that are all the y values that are smaller than 1/3 of the x values plus 2. The weird part for this one, the last one, is that it's the same as this, except the line itself doesn't count. Okay, similar to how we had to use an open circle there. On a number line to show that this is where it starts, but we're not counting that value. Very similar thing going on right here. So really quickly, kind of sum that up. All of these have ranges of answers, but whereas the first one is represented just by a simple line, the other two will need to be a line plus some shading. Okay, so how to graph? It's really pretty easy. You graph the line as if it were an equal sign. Graph the line as normal, okay? So you could be using slope-intercept form, you could be making a table, you could be using point-slope form, whatever. Then, if it's greater than or less than, instead of drawing a line, a solid line, you're going to draw a dashed line. That's to show that that's a border, but it doesn't count. So similar to the open circle that we use on the number line. If it is greater than or equal to, less than or equal to, we would just use a solid line there. And then finally, you are going to shade half of the graph. Okay, because 1/2 of the graph is going to contain all of the greater than lines or less than lines. Think of a number line. Like when you graph x is less than 2, you make an open circle on 2, and then you shade everything to the left, because all of those numbers are less than 2 as well. And the way you're going to figure out where to shade is with a test point. I'm going to show you how that works. Okay, so the way that we graph a system of inequalities, which is what we're going to jump right into, is you're just graphing both these graphs on the same line, shading both these graphs on the same line, and seeing where these shaded regions overlap. Okay, so here's what I want you to do. I want you to, if you don't have two different colors of pen, or maybe a pen and a pencil, something like that, I want you to pause and go get that now. I really want you to be using two different colors here if possible. Okay? And then I want you to pick one color for this first line, and a different color for the second line. Okay? And then what I want you to do right now is just graph both of those lines. Graph both of those lines. In the first one, since it's greater than, when you actually connect the line, make sure you draw a dashed line. And in the second one, make sure you use a solid line because it is less than or equal to. Just draw the line. Don't worry about the rest of it yet. Okay, pause and then come back. It's a good review of graphing. Okay, both of these are in slope-intercept form. So in the first one, if we had simply y is equal to negative 2x plus 1, we'd graph a y-intercept of 1, and then to make new points, we'd go down 2 and over 1. So you can see I'm doing that right now. I'm going to make as many points as I can because it makes it easier to draw the line out. I have a big ruler that I can just slap on here. Okay, and then since it's greater than, we know this is just a barrier, so we're going to draw a nice little dashed line here. I'm making it, I don't know, almost more dotted, but dashes, dots, all good. Okay. Then for the second one, if I had the equation y equals x plus 3, I would go to 3 on my y-axis, that's my y-intercept, and I'd make new points by going up 1 and over 1. And here, I can make a solid line because I do want to include the points on that line. Now, for each of these lines, that's not it, okay? Because all I did is graph if it were equal to. Now, if I want to figure out which half of my line, let's look at the first one, has y values that are greater than negative 2x plus 1, what I'm going to do is I'm going to do a test point. So what I like to do is I like to see, I'm going to draw a big green dot right now on 0, 0. That's the point I'm going to test. Okay, so if I plug in x equals 0 and y equals 0, I want to see what I get. If I do that in my first one, I get 0 is greater than 1. If I plug 0 in for y and 0 for x, in the first one I get 0 is greater than 1. That's false. So 0, 0 should not be a part of my answer. Since 0, 0 should not be a part of my answer, that means I need to shade on the other side from it. Now when I say shade, I don't mean fill in completely. I just kind of do a little bit of light shading like this to show that that whole side contains values that work. And you could try anything you want. Try plugging in 10, 10. You get 10 is greater than negative 19. You get true stuff everywhere on the other side of that line. For the other one, again, I'm going to try 0, 0 again. When I do that for the second one, I get 0 is less than or equal to 3. That one is true. So since 0, 0 is like on the bottom half of that line, I want to shade the bottom half. So the area of the graph that contains all valid answers to both of these inequalities, that's right in this region. Now I'm going to use a third color. You don't need to do that. You don't need to go that far necessarily, but this is the region of my answers. Now, what I usually like to do at this point is if I've shaded lightly enough, I kind of erase the other regions, or maybe I just make this region a little bit darker, more noticeable, but I want to make it apparent that this region is a region where both inequalities are true. You could try any point over there, guaranteed. It would work for both inequalities, and it's the only region on the graph in which that would happen. Okay? So, I'm going to have you try another one on your own. And it's really important to do that test point, okay? Because there are situations where it's, in this case, the greater than one, the green one, I shaded above. The less than one, I shaded below. It seems like that makes sense, but that won't happen every single time, especially depending on where negative signs are. Okay. Here's what I want you to do. Try both of these next two. Again, you're graphing it as if it were an equal sign, and then you just need to shade one half of the graph. The way you figure out which half to shade, is by using a test point. So do both of these, pause, and then come back. Okay, so like for this one, I'm going to use red for my first one this time. We have 5x minus y equals negative 6. You have a whole lot of different choices here. You really do. You could make a table of values, or you could transform it into slope-intercept form. I'm going to transform this into slope-intercept form. I'm going to add y and add 6 to both sides. That gives me y equals 5x plus 6. That's much easier to graph. So I'm going to graph that, make a dot at 5, and then at 6, excuse me. And then I'm going to go up 5 over 1 or down 5 left 1. Okay, so my up 5 over 1 is there, down 5 over 1, down 5. over 1. And since it's a less than line, so I want to definitely be using a dashed line here. Okay. So that's my first line. I'm not going to do my shading yet because I don't like it to get in the way of the other graph. Then I'll do blue for the second one. Again, I'm still graphing the line as if it were just a regular equals sign. This one, yeah, I'm still going to transform it into slope-intercept form because I get y equals 3x minus 4. That's just such an easy thing to do. But if you made a table of values, that's fine too. So I'm going to start at -4. And then I'm going to go up 3 over 1 to make new points. I'm going to make as many of them as I can. Couldn't make too many for the last one because the slope was so large. Okay, and again, I am making a dashed line. So now this one, it's a little bit weird because these lines probably won't really intersect until, you can kind of tell where they're going to intersect. They're going to intersect probably somewhere down just off the bottom of the screen. Okay, so the first one, again, if I do a test point here, and with your test point, use the original equation, whatever you had originally is what you want to use, okay? So if I do the test point 0, 0 for this one, I get 0 is less than -6 when I use that test point. That is false, so I want to shade on the top side. See, that one had a less than sign, but I ended up shading on the top half. Okay, and then the next one, 0, 0, gives me 0 is greater than 4. That one is also false, so I need to shade on the bottom side over here because I don't want to shade that 0, 0 in. So what's really interesting about this one is that there isn't actually an overlapping region. Okay, really quick over to the side here, kind of what this one would look like if we had a little bit more space. If we had a little more space and we're able to get off the bottom of that graph a little bit, I kind of ran out of room. We'd find out that this is the little region right here where those two ranges intersect. We just didn't really have enough room to get that far. And that's okay, and sometimes it's going to happen. You'd have to extend your graph or do something like that. Okay. Last one should be pretty easy if you remember how to graph y equals 0. Y equals 0 is just a horizontal line right on the x-axis, and we're going to make it a solid one. And y is less than x minus 5, or less than or equal to x minus 5. We're going to use slope-intercept form. And we're just going to be going up 1 over 1 to make new points. Okay, we're going to connect those with a line. Again, a solid line because it is or equal to. And now we just got to figure out where to shade. Now, we can't use the test point 0, 0 on this line, but hopefully it's obvious that if we want y values that are bigger than 4, those are going to need to be above the line. And if we try our test point of 0, 0 in the next one, we get 0 is less than or equal to -5. That's false, so we want to shade below the line because that's away from 0, 0. And I think we can see the region where those overlap. It's this nice little triangle region right in here. So I'm just going to make that a little darker. And again, I've seen people do it different ways. I've seen people, some people are very good at just using a pencil and erasing, or making sure they use erasable pens and erasing. And some people just shade very, very lightly at the beginning, then they make sure to shade that region in dark. So for all of these, for these linear inequalities, these systems of linear inequalities, the only difference in graphing is that you have to do some shading at the end. And then instead of figuring out just where the two